Good morning students. Today we shall continue our class, additive manufacturing class. We were discussing in the previous class regarding the CNC technology. We briefed out the introduction regarding NC machines, CNC machines and DNC machines. We have also discussed the classification of CNC machines. We have discussed the advantages, disadvantages and applications of CNC machine tools. Today we shall discuss the other topics from this chapter. Today we shall concentrate on components of CNC machine. So what are the different components of a CNC machine? A CNC machine basically consists of three components. The first one is called as a part program and program input device. The second one is a controller unit, which is also called as machine control unit, abbreviated as MCU, and the third one is a machine tool. Let us discuss about these things in detail. The first one is a part program and program input device. What is a part program? So in my previous classes we discussed that our part program is nothing but it is a set of instructions written by a part programmer. It is composed of letters, numbers and symbols that are required for the movement of the machine tool, and also it consists the instructions regarding the on and off control of the auxiliary functions such as spindle rotation and coolant on off, etc. These part programs are written by a person who is familiar with these instructions, coded instructions, and these are entered to the machine control unit through various input devices like punch tape, magnetic tape or a computer. The second component is a machine control unit. Machine control unit or MCU is the heart of a CNC machine. It is made up of a number of electronic components. These electronic components are used to perform various functions, such as they are used to read the coded instructions, they are used to decode the coded instructions, they are used to implement the interpolations such as linear, circular and helical to generate the axis motion. They are used to provide the feed to the axis motions to the amplifier circuits for driving the axis mechanism. They are used to receive the feedback signal of the position and the speed of the drive axis. They are used to implement the auxiliary control functions such as coolant or spindle on off and tool change. So these are few functions that a machine control unit does. When these electronic components are incorporated in this machine control unit, they perform these following tasks. They try to read the instructions they are given and they try to decode them. They try to generate some proper motion to the cutting tool. They are used to receive the feedback signal and they are also used to function for the coolant off, spindle on off and the tool change also. This is the block diagram of a CNC machine. So in the figure or in the block diagram we can see the various blocks. The first one is an input device. So these input devices may be punched tape or a computer through which the part programs are fed to the machine control unit. The machine control unit consists of two blocks, that is a data processing unit and a control loop unit. This data are processed inside this machine control unit and the data is fed to the driving system, which helps for appropriate control of the motion of the machine tool. The control loop tries to carry out some other miscellaneous functions such as coolant off, on, all. So these will be fed to the machine tool. The mixed data that are received by the driving system and the machine control unit are sent to the machine tool, and the machine tool sends the appropriate feedback system, the feedback elements such as the position and the velocity, and the same thing are again fed back to the machine control unit, so that until the cutting tool and the work table are set to the desired position, this loop will be executed. And later, once the cutting tool and the workpiece positions are set, the work will be carried out by the machine tool and it will be used to display on a display unit. So that's what we have discussed. So the explanation is given here. So this is a typical MCU which will consist of a tape reader or a buffer or a signal output channel to the machine tool. So the feedback channel from the machine tool will try to control the number of feedback signals that are received, and the sequence control will be used to coordinate the overall position or the overall operation for the production of the part. Later we have a machine tool there. The machine tool will try to perform the actual operation required for the machining. It will control or it will consist of the work table and the tool, cutting tool, spindles that are used to move to a desired position. Once these are set, okay, the driving system will try to receive the commands from the MCU, and the driving system will consist of amplifying circuits, drive motors such as AC or DC servos, and ball lead screws. The feedback system is also referred to as the measuring system. It uses position and speed transducers to continuously monitor the position at which the cutting tool is located. This MCU uses the difference between the reference signal and the feedback signal, so that it will try to see that the controlling signals are set for the correct position and the errors are being eliminated. Let us now discuss the part programming methods. The part program is nothing but it is a sequence of instructions as described in my previous classes, and the purpose of writing this part program is to see that the part will be executed based upon the instructions. So this part program will try to describe what should be the nature of work that has to be done on the part, and that work has to be done by the computer, that is a numerical controlled computer program. This part program is written by a part programmer and it can be written in two different techniques. So the part programming can be done based upon two different techniques. The first one is called as a manual part programming and the second one is a computer aided part programming. So part programming can be of two types depending upon the two techniques. One is manual part programming and the second one is computer aided part programming. What is a manual part programming? Manual part programming is a method in which the part program or the data required for machining is written manually. Hence it is called as a manual part programming. So a manual part programming is nothing but the part program will be written manually in a standard format. There is a format for writing the program and these programs are written using low-level machine language such as G codes and M codes are used to write such type of programs. The various operations necessary to produce the part with specific cutting tools, so spindle speeds, feed, depth of cut, cutting fluid circulation, tool workpiece motion, etc. will be included in this program. So a manual part program is a one which is written manually, and this type of part program is written in a low level machine language using G codes and M codes, and it includes the operations required for performing the machining of the workpiece. It may include the cutting speed, feed, depth of cut, cutting fluid circulation, workpiece motion, tool motion, etc. Manual part programming is suitable for simple profile. So we can adopt the technique of writing a manual part programming only when the profile is a simple one. The second type of part programming is computer aided part programming. This method of part programming is suitable for complex contours. In this method, a computer is used to generate the program for producing the part. Here, when we make use of a computer, the burden will be reduced on the programmer, and also it will try to improve the accuracy of the part that is produced. Here, the programmer has to specify two things. One is the workpiece geometry and the operating sequence and the tool path. Once the programmer has specified these three things, that is workpiece geometry, operation sequence and the tool path, the data are fed into the system. The computer will be carrying out the computational tasks and will generate the part program automatically. So such type of system will make use of high level languages such as apt, also known as automatically programmed tools. They also make use of other high level languages such as adapt, split, romance, etc. These are the high level languages that are used to write the part program. These high level languages are nothing but they consist of English like statements, and once the program is written in English like statements, a translator known as a compiler program is used to translate these statements into an acceptable format of the machine control unit. So a compiler program is used to translate this in a form that is acceptable by the machine control unit, and hence the program will be used for producing the part very easily, and it is automatically done by the computer. Hence such type of programming are called as computer aided part programming. So manual part programming is the one which is written manually, and computer aided part programming is the one which is making use of a computer to generate the program. Let us now discuss the coordinate systems. Before starting the program, the programmer must decide or establish the origin or the datum point from where he will try to measure the distances or the position of the tool and the movement of the cutting tool with respect to the workpiece. So that is called as a coordinate system. The coordinate system can be established by two methods in an NC machine. The first one is called as absolute coordinate system, and the second one is called as incremental coordinate system. Let us now discuss these two types of coordinate systems in detail. Absolute coordinate system. In this type of coordinate system, all the measurements are taken from the origin, that is the coordinate system wherein x is equal to 0, y is equals to 0 and z is equal to 0. Figure shows below an absolute coordinate system with fixed origin. Absolute coordinate system can be carried out by again two different methods. One is called as a fixed origin system and another one is called as floating origin system. In the figure below, we can see the absolute coordinate system with fixed origin. In case of fixed origin system, the origin is always chosen as the lower left hand corner of the work table. So we can see the circle that is indicated, two concentric circles we can see in the figure. This indicates that it is the origin, that is the lower left hand corner of the work table is chosen as the origin in case of fixed origin system, and all the measurements will be positive when you choose the lower left hand corner as the origin. So therefore the measurements all will be positive and the movement of the cutting tool are with respect to the origin O only. So we can see in the figure there are three holes that are to be drilled, and the position of all these three holes are taken from the origin O. Coming to the second type of absolute coordinate system, that is called as a floating origin system. In case of floating origin system, the system will allow the operator to locate the workpiece in any convenient position on the machine table. It is left to the operator to decide that the origin can be chosen based upon the operator's interest. So usually the symmetrical objects, in case of symmetrical objects, the origin will be chosen at the center so that we get both the positive and the negative measurements in the workpiece. So a floating origin is the one which allows the operator to locate the workpiece in any convenient position, and usually for symmetrical objects the origin is chosen at the center so that both positive and negative measurements can be made. This is the first type of coordinate system, that is called as an absolute coordinate system. In absolute coordinate system there are again two types, fixed origin system and floating origin system. Coming to the second type of coordinate system, that is incremental coordinate system. In this type of coordinate system, all the measurements for the next position of the cutting tool are calculated from the tool's present location, which is taken as the origin point. So every time the tool will be changing its position. So where the tool is standing in the previous position, so that itself will be taken as the origin. So in case of incremental coordinate system, the measurements for the next position of the cutting tool is calculated based upon the tool's present location. Suppose we need to take the data or measure the coordinate system for the next position, then based upon the present position of the tool we take the measurements. Let us now discuss the next topic, that is the structure of a NC program. In manual part programming, as we discussed, the programmer writes the part program manually using M codes and G codes. So in manual part programming, the data that is required for machining is written in a standard word address format consisting of English-like statements. The program will be written by a person known as part programmer. The program is written in the form of blocks. Blocks are nothing but it is a program statement or a program line. This block is a collection of complete group of NC words that commands the machine control unit to perform the specific task. Each block or a program line will contain addresses which will appear in the order specified below. So I have written a set of alphabets here: N, G, X, Y, Z, F, M, S, T. So these alphabets should be in the same form whenever we require to perform any particular task. So the particular alphabet should be called in the same format, and this set of blocks, the set of instructions will be written in the form of a block or a program line in the same format. So therefore This order only should be maintained whenever we write a block in a program. Although it may not be necessary for us to call all the addresses. So each and every alphabet is called as an address. So it may not be necessary for us to call all the addresses, but the order should be maintained throughout every block in the program. So here we can see the structure of an NC part program. So figure shows the structure of an NC part program. In the figure we can see that all the addresses are appearing as I discussed. So N, G, X, Y, Z, F, M, S, T. So the block, we can see a block consisting of all these addresses. So what does each block specifies? So the first address, that is N, it refers to the block number. The second address G refers to the G code used. So that is a preparatory function used. The addresses X, Y, Z tries to refer the distance traveled by the tool in X direction, Y direction and Z direction. The address F refers to the feed rate and M refers to the miscellaneous function or M code. S indicates the spindle speed and T indicates the tool number or the tooling management. And the last one we can see in the block, it is end of block. So this is the structure of an NC part program in a block. Let us now discuss what are these preparatory functions. The preparatory function determines how the tool has to be moved to the programmed target. Why do we make use of preparatory function? We make use of preparatory function in order to decide how the tool has to move to the programmed target. So to make the tool to move to the programmed target, we require some control commands. So to initiate the control commands, that is, we make use of a machine control unit. This machine control unit must be ready to perform a specific operation and try to interpret the data. How to interpret that this is the particular operation that has to be done. So for this, the G codes are represented by a 2-digit number from 00 to 99. So it is represented by a character G followed by some 2-digit numbers that are between 00 to 99. Few of the G codes are listed as below. These are the standard G codes. So here I have tried to list some few of the G codes. So here G00 indicates rapid traverse. G01 indicates a linear traverse. G02 indicates the clockwise circular motion. G03 indicates counterclockwise circular motion, and G21 indicates that it is for metric units. So 00 rapid traverse, 01 linear traverse, 02 clockwise circular motion, 03 counterclockwise circular motion, and G21 metric units. These are few of the standard G codes used in a program. Few of the M codes, wherein M stands for miscellaneous function. So some of the common standard M codes are M00, which indicates the program stop. M01 indicates optional program stop. M02 indicating end of program. M03 stands for spindle rotation in clockwise direction. M04 indicates spindle rotation in counterclockwise direction. M05 indicates spindle stop. M06 indicates tool change. M08 indicates the coolant should be flooded and it should be on. So flood coolant on. These are few of the standard M codes and G codes. Coming to the next topic, that is computer assisted part programming. So till now we have discussed the manual part programming. Now we shall discuss computer assisted part programming. So computer assisted part programming is always done using apt programming, automatically program method. So in computer assisted part programming, the machining instructions are written in English like statements as I discussed. So they may be apt and Romans, adapt. So such are the English languages. So here these English like statements of the NC programming language are processed by the computer to prepare the tape. Computer assisted part programming has two parts. One of the tasks has to be done by the part programmer and half of the task will be done by the computer. So in a computer assisted part programming, a part programmer has to perform two tasks. One is he has to define the geometry of the work part and he has to specify the tool path and the operating sequence. So which are the two tasks that a part programmer has to do? One thing, he has to specify or define the geometry of the work part. Secondly, he need to specify the tool path or the operating sequence. The second one is the computer's job. The computer's job is to input the translation, arithmetic calculations, check the cutter offset computation and the post processor. So these tasks done by a part programmer and tasks done by a computer are shown in the form of a block diagram below. So figure below shows the steps in a computer assisted part programming. We can see the first row in which a part programmer has to specify the part geometry definition. The tool path he has to specify and then he has to input this to a computer. Then what is the work of the computer? The work of the computer is to input the translation, then check for any arithmetic calculation, check for the cutter offsets, then all these informations will be sent to a post processor. It will process according to the information received by all these things and then it will send to the machine tool, wherein the machine tool will act accordingly. So the tool will be given some motion and the tool will try to move and perform the required task. Let us now discuss on APT, automatically programmed tool. APT stands for automatically programmed tool. So what it is? It is a high level computer programming language which is most commonly used to generate instructions for numerically controlled machine tools. So we make use of this tool to generate instructions for numerically controlled machine tools. APT is a three-dimensional NC programming system. So you can use this APT for a three-dimensional programming system. It is not only a language, but it is also the computer program that will process the statements, APT statements. It will calculate the positions of the cutter and generate the machine tool control commands. This APT language consists of four basic type of statements. whenever we write a program using apt system or apt language, it will consist of 4 types of statements. What are those 4 types of statements? The first one is called as a geometry statements. The geometry statements are those which will try to define the statements with respect to the geometric elements of the part. For example, line, circle, etc., point. So all these statements are specified by using geometry statements. The second statement are known as motion commands. These motion commands are used in the apt language to specify the tool path. The third statement is called as a post-processor statement. Post-processor statements will try to control the machine tool operation. For example, they are used to specify the speeds, feed. They are used to set the tolerance values for circular interpolation and other operations that are required to actuate the machine tool. The fourth statements are called as auxiliary statements. Auxiliary statements are nothing but they are miscellaneous statements which are used to name the part program. They are used to insert comments in the program, and they are also used to accomplish similar such functions. So an apt language will basically make use of 4 different types of statements. They are geometry statements, motion commands, post-processor statements and auxiliary statements. All these statements are constructed using vocabulary words, symbols and numbers. All these are arranged using an appropriate punctuation. That means there may be a comma to separate 2 words. So therefore, the apt language will make use of vocabulary words, symbols and numbers that are arranged using appropriate punctuation. Let us now discuss these statements with some example. So geometry statements. The format for specifying geometric statements is symbol is equal to geometry type / descriptive type. So this is the format how we specify a geometric statement. For example, if we want to specify a point in a given work, so the point is indicated as P1 if it is a first point. If it is a second point, it may be indicated as P2, P3 if it is a third point, henceforth like that. So here is an example wherein one point has to be specified. So P1 is equal to point / the descriptive data, that means its distance in x, y and z direction. So it is given here as 20, 40, 60. Similarly, lines are indicated as L1, L2, L3, L4. So based upon the number of lines. And here I have given an example of 2 lines like L3 and L4. So we can see how they can specify. So L3 is equal to line / P3, P4. So what does P3, P4 indicate? They are point. So therefore L3 is a line which will be drawn from point P3 to P4. Similarly, other commands can be used such as a circle. So how to specify a circle? So a circle is specified as a C1. C1 is equal to circle / center. You need to specify its center, comma, at what point, and suppose we want to draw a circle at point P1. So at point P1, the center of the circle will be located and the radius of the circle is 25 mm. So this is how we specify circle. Similarly, plane. So a plane is written as PL1. So this is how a plane is specified. So plane slash P1, P2, P3. So if these 3 points P1, P2 and P3 are joined together, then we get a plane. Similarly, we'll discuss some other commands like motion commands. So the format for specifying a motion command is motion command slash descriptive command. So as we discussed, motion commands are used for directing the motion of the tool. So we can see here one of the example, go to slash P1. So the meaning of this statement is that the tool has to go to a point P1 and perform the required task. Similarly, post-processor statements, the format of these post-processor statements are post-processor command slash descriptive data. For example, we want to make the coolant on off, so therefore coolant slash flood. It indicates that the coolant has to be made on and it is to be flooded. Similarly, another post-processor statement is here below, that is spindle slash 1000. So 1000 indicates the RPM with which the spindle has to rotate, and CLW indicates the clockwise rotation of the spindle. So RPM, clockwise. So a punctuation is used, comma, to separate these two descriptive data. The fourth one is an auxiliary statement. So auxiliary statements are nothing but they are used to just specify such as part numbers. So why do we make use of a part number in a program? It is used for identifying that it is the first part that is produced. So part number is the first statement, always the first statement in a apt program, and this is used to identify the program. So similarly, we may use FINI, which indicates which is nothing but it is a abbreviation of finish. So FINI indicates the end of the apt program. So few of the statements that are used in an apt program are geometry statements, motion commands, post-processor statements and auxiliary statements, and their examples I have discussed here. So with this we'll try to complete, or we'll stop with this today's class. We shall discuss the different, we have discussed in this class regarding the various components of a NC machine, the different programming methods, the different methods of specifying the coordinate system. We have also concentrated on computer assisted part programming. We have also discussed what is meant by apt programming and the various statements that are used and the format in which these statements are used. With this, we complete the 5th module. Thank you. We'll wind up our class. Thank you.